Hello everyone, my name is Millie Jain. I'm a physics tutor and welcome to my AP Physics class. Today I'm going to discuss a problem over energy conservation. Okay, so there is a problem on your screen. It says you put a spring with spring constant K1 just before the bottom of a frictionless ramp with angle theta and a spring with the spring constant K2 at the top. So we have two springs, one placed at the bottom and another placed at the top of the ramp. Then you push a cart with mass m into the spring, first spring, so that it compresses by the distance delta r1. When the cart reaches the top of the ramp at height hf, about its initial height, what is the furthest that the second spring is compressed? Okay, so here a lot of work done and the energy transfer is going on. So initially, what is happening that you put your energy into the system for compressing the mass m against the spring. Then obviously due to the elasticity of the spring will push back this mass and will raise it to the height hf, and then when this mass reaches to the height, it will encounter with the second spring and compresses it with the compression of delta x2 that we need to find. Okay, so and also in the problem it is given that the ramp is frictionless and also there is no hint of any air resistance. Therefore it is a completely conserved system, that is the energy is going to be conserved, which means we can write that E initial is equals to E final, or delta E is equals to 0. That means energy is just transferring from one point to the another point and keeping the energy of the whole system as the constant. Here the system refers that obviously the when you are doing a problem over energy conservation, the system matters a lot. Okay, so you should write, like whenever you are solving this type of the problem, you should mention that what is your system. So here we have the system as our two spring, then rim, then the earth. Because why I'm taking earth? Because there is an involvement of gravitational potential energy when it is going to height hf. Yes, and then obviously the mass. Okay, so actually this square box, this diagram is like it is in this square box. So this is our closed system. Okay, now what are the energies involved in this closed system? Like what kind of energy transfer it is happening here? Look, initially we have the spring potential energy, right? So when the mass is going up, this spring potential energy is converting into what? Kinetic energy and the gravitational energy. And then when it reaches the top of the ramp, the kinetic energy, because kinetic energy is converted into the spring potential energy for the second spring. So at the last stage, at the final stage, it will have what energies? The gravitational potential energy due to the height and the spring potential energy due to the second spring. And initially it has only the spring potential energy, right? And in between it has kinetic and the gravitational energy. Okay, so now we obviously this we need to write an equation ei is equals to ef. So we need to decide 2 points between which we are going to conserve the energy. Look, at every point in this system the energy is conserved, like if you take this 2 point, any 2 point. But we have to be very smart here. We have to take such 2 points so that those points include this compression delta x, because that we need to find, and the all the other terms are known. Okay, all the other things or the other things in the equation are known, because we have only one equation here, right? So for that what I'm using my first point or my initial point as this compression, because the compression is given as delta r1, right? And in between there is a kinetic energy, and we don't need to find any velocity kind of thing, so I will not use any point from here. Then I'll use my second point as this compression and this height, because this is what they have asked us, right? So my initial energy or the E1, anything, is what it is, just spring potential energy. So since it is a problem solving class, I'm just assuming that you know the formulas, right? So the spring potential energy is given by 1/2 spring potential constant, spring constant, and the compression is delta R1 whole square, right? Next is, okay, the E final, the second point energy. So as we have discussed, at that second point, we have the spring potential energy due to the second spring and the gravitational potential energy due to the height h, right? So this is going to be half K2, the spring constant of the second spring, and the compression is given that we need to find delta x2 square plus the spring gravitational potential energy is given by mass g and the h, right? And one more information given in this problem is that delta x2 is very less than hf, which is required, because while we are writing for the gravitational potential energy, it should be exact height. Okay, it should not be altered due to this compression. So that's why it is given like that. Okay, next is, so that's it, energy is conserved, so we can equate these two energies, right? So this is going to be 1/2 K1. So this is just the transfer of energy. So work done and etc. Work done is basically just transfer of energy from one form to the another form. That's it. By applying force. So here the first spring is applying the force on the mass, and that's why it is going up there. All right. So here we need to find what? This delta x2. So this is just the algebra. I'm going to isolate this delta x2. All right. So I'm subtracting this mgh quantity from both the sides. So this is going to be half k1 delta I1 square subtracting mgh equals half k2 delta x2 square. Yes. Then what we will do next? Multiply. We also want to remove these two things. So we'll multiply 2 on both the sides and divide k2 on both the sides, right? And then also we can take the square root as well. So the final value we will get, right? So multiplying 2 on both the side and dividing k2 on both the side will give us half k1 delta r1 square minus mg hf taking under root equals to delta x2, right? So this is the expression for delta x2. Okay, bye bye, take care.